Advanced Data Encryption Method based on the Monochrome Pixel Alphabet. Introduction and Literature Review. In the current stage of information technology development, the issue of safeguarding the confidentiality of information resources is becoming increasingly relevant, timely, and important. This is primarily due to the intensive scientific and technical progress in the field of information security, information, and cybersecurity, and, as a result, the advancement of hardware and software information technologies. These advancements pose a threat to important information that is transmitted, processed, and stored by ICS. At the present time, various cryptographic protection algorithms are employed to ensure an adequate level of information and cybersecurity, achieving the fundamental properties of information. These include encryption for confidentiality, hashing for integrity control, and electronic digital signatures for availability, authentication. However, statistical data from global government response teams to cyber incidents indicate an increase in the number of attacks in the global and national cyberspace. This includes cyberattacks of the access type, whose purpose is to gain unauthorized access to important confidential and/or personal information of citizens and government officials of Ukraine, among others. The development of highly effective methods for cryptographic data protection is an important component in addressing information and cybersecurity concerns. The primary goal is to ensure a high level of cryptographic security in the developed encryption algorithms. Cryptographic security and methods of cryptographic data protection refers to the property of cryptographic algorithms and cryptographic protocols that characterizes their ability to resist cryptographic analysis methods. The development of highly effective methods for cryptographic data protection is an important component in addressing information and cybersecurity concerns. The primary goal is to ensure a high level of cryptographic security in the developed encryption algorithms. Cryptographic security and methods of cryptographic data protection refers to the property of cryptographic algorithms and cryptographic protocols that characterizes their ability to resist cryptographic analysis methods. 2. Therefore, despite the existence of a lot of the number of known encryption algorithms, unauthorized access to information and access-based cyber attacks leading to data leaks and violations of the fundamental properties of information, which regulated by information security policies, are still prevalent. 3. Thus, there is a need for the development of a new cryptographic method that combines the mathematical properties of steganographic and cryptographic systems to provide robust information protection. The known methods only consider either the cryptographic or steganographic properties of data protection algorithms, and therefore are incapable of resisting cryptographic attacks or attacks on the cipher. Let us analyze these methods. In scientific projects, authors have proposed the new technique of steganography based on the use of LSB method for raster images of different colorful models for higher security and reliability level achievement. In the scientific project, a mechanism for one-to-one information exchange with individual persons by concealing it from the rest of the group is developed. Given their availability, digital images are the most suitable components for use as containers compared to other objects available on the Internet. The technique proposed encrypts the message within an image. In the scientific project, the authors propose approaches to combining cryptographic and steganographic properties for information protection. Their solutions are based on methods such as LSB, DDT, and well-known symmetric and asymmetric cryptographic data encryption algorithms. Therefore, in the scientific projects, the authors propose an advanced steganographic cryptographic system that combines the features of cryptography and steganography. And various combinations of cryptographic and steganographic methods are explored, highlighting that steganography based on DVT with advanced encryption standard, AES, provides a higher level of security while preserving image quality. Additionally, a combination of the data encryption standard, DES, cryptographic algorithm, and LSB steganography for ensuring information confidentiality is suggested in 10. The analysis of scientific achievements indicates a large number of possible, promising, and implemented combinations of steganographic and cryptographic methods for information security. However, All of them are based on the use of known and outdated algorithms, the study of cryptographic stability of which indicates the imperfection of these cryptographic systems. This is due to the possibility of successful implementation by the violator of the UAA in attacks on the cipher, and it is carried out in order to violate the integrity and confidentiality of information that circulates in information systems or systems such as sender-recipient. To achieve goal, it's necessary to form pixel alphabet equal 1, 2, 3, 4 for Ukrainian and English alphabet symbols, numbers, and punctuation symbols. Synthesize and detail method stages, which takes into account cryptographic and steganographic algorithm properties of information security. After that, for outgoing message equal 1, conduct verification of suggested method, conduct research of studying the impact of the parameters of a graphical container on the effectiveness of the proposed method. Materials and methods. The proposed data encryption method, which combines the mathematical properties of steganographic and cryptographic systems, and is based on the use of a pixel alphabet of a monochrome image, consists of 5 main stages: forming the pixel alphabet, creating the pixel matrix, key pair generation, encryption, forming ciphertext, and decryption. A detailed scheme of the functioning of the developed method is presented in Fig. 1. Let's describe each of the method's stages in detail. In the first stage, a specific static range of values 000-255 is assigned to every possible character of the output message that can be used in the message. This range corresponds to the brightness range of pixels in a digital raster image, where 1 for letters in Ukrainian alphabet, 2 for letters in English alphabet, 3 for numbers, 4 for special symbols and punctuation. Figure 1. Block diagram of the proposed method. The possible variant of pixel alphabet can be presented as follows. For letters in Ukrainian alphabet, the example for numbers of synthesized pixel alphabet is presented. It is worth mentioning that symbols for message choose out of the static range that increases, which in turn increases the level of cryptographically resistant of such an algorithm. The pixel alphabet is synthesized on one side of the information exchange and transmitted to the other side through secured data transmission channels, or is coordinated without any third party. That is, the pixel alphabet is generated or agreed upon only between the recipient and sender. Besides this, advisable to change the pixel alphabet periodically. The next step is the formation of a pixel matrix. At this stage, an image with a consistent color model, usually monochrome, is arbitrarily selected, and the number of blocks into which it will be divided and numbered is determined. For each block, the average brightness values of the pixels are calculated, where the block numbers, which are then recorded or mapped into the pixel matrix. Similarly to the alphabet, it is advisable to periodically change either the image itself or the number of blocks into which it is divided. It's worth noting that the choice of a raster image and the number of blocks are coordinated by both sides of the exchange, and for algorithm usage, only the pixel matrix is retained. During the generation of a set of encryption keys, the sender arbitrarily selects block numbers from the pixel matrix and their corresponding average brightness values, which determine the encryption key. The main step of the method is the process of encrypting information. Each character in the original message is replaced using the synthesized alphabet with a corresponding value from its assigned range. Then, a set of sums is calculated between the transformed message into the pixel alphabet and the corresponding values of the pixel matrix using the encryption key set. Afterwards, the ciphertext is calculated as. It's worth mentioning that to obtain the ciphertext, the corresponding values are used in the hexadecimal system. This rule also applies to transmitting the ciphertext. As a result, the ciphertext appears as a sequence of pairs of ciphertext values, 16, and block numbers, 16, each character of the message. A notable feature of the method is that multiple characters can be assigned to the same block, which further enhances the algorithm's cryptographic resistance. On the recipient's side, the reverse process of encryption, decryption, is performed. The result of this stage is the retrieval of the original message. Experiment, results, and discussions. In order to confirm the functionality of the proposed enhanced data encryption method based on the monochrome image alphabet, an experiment was conducted using the verification method selected in reference 16. To conduct the experiment in the Python programming language, the method proposed in the article was implemented. During the experiment, encryption of the open text message was performed based on the developed method, followed by the transmission of the ciphertext over a network, and then the decryption of the received ciphertext on another host. So, for conducting the experiment, the following original message was chosen: cybersecurity. According to the first stage of the method, all characters of the input message were transformed based on the proposed technique outlined in 14 alphabet encryption of letters of the English alphabet. In this way, the input message takes the following form. In the next stage, a test image with dimensions of 264 by 192 pixels was selected and divided into 25 blocks, 5 by 5, using the Python imaging library, PIL, library. The average brightness values of the pixels in each block were calculated, and a pixel matrix was generated. After the formation of the pixel matrix, the encryption process of the message takes place. To encrypt the characters of the message, a set of keys was generated by randomly selecting block numbers from the pixel matrix and their corresponding average brightness values using the random module. The number of keys corresponds to the number of characters in the message being encrypted. Therefore, during the experiment, a set of block numbers from the image. Mathematically, the set of keys has the following form. In the next stage, the sum is calculated according to expression 5, transformed into the pixel alphabet message 7, and the corresponding values of the pixel matrix, table 3, are used with the encryption key set 8. As result, the following values are obtained. In the final stage, before sending the message to the recipient, it is transformed into ciphertext according to expression 6. As a result of this transformation, obtained message has the following form. Therefore, by using the proposed method, the encrypted message is presented in the hexadecimal numbering system. The recipient receives tuples of pairs consisting of ciphertext values 10 and block numbers 8 for each character of the message. Conclusions. The scientific novelty of obtained results involves improving the data encryption method based on a pixel alphabet by changing the order and mathematical apparatus. The proposed method, unlike known and existing ones, does not utilize the functionality of cryptographic and steganographic encryption systems, but rather their structural properties. It provides an adequate level of information confidentiality and possesses a sufficient and necessary level of cryptographic resilience. The mathematical apparatus of the data encryption method implements the concealment of the message content, while the pixel matrix and its usage represent the very existence of such a message. By using the blocks into which it is divided as mathematical components of encryption, namely their average pixel brightness values obtained at the stage of pixel matrix formation, the practical orientation of the study lies in the ability to apply the proposed data encryption method to ensure secure and confidential exchange of important information between organizations and institutions. Prospects for further research include improving the mathematical apparatus of the encryption method, considering pseudorandomness and the dynamic formation of the pixel alphabet, and utilizing various color systems for raster images. Thank you for your attention.